Hi, everybody. So today we are going to be going over our notes portion for atoms and kind of about how the periodic table works. Now, we're really not going to get too much in detail about the periodic table yet, just because we're not at that point in the year. However, this will be a good preview for kind of what the periodic table is, what we use it for, and how atoms are represented using this periodic table through this reference tool. So the first thing we want to talk about, and this kind of ties back to what we had learned in our previous unit, which was how matter, which is all the stuff in the universe with the exception of energy, how all of that stuff gets organized. And what we end up seeing is that elements are the smallest form of matter that we can have. So elements are substances that can't be broken down. So all of the things that exist within the universe that are matter are made up of some combination of these periodic table of elements. So literally everything that exists contains one or more of these elements. So you look at something like H2O, it's made of hydrogen and oxygen. You look at something like sugar, which is C6H12O6, that's made of, carbon, hydrogens, and oxygen. So everything that exists that is matter is made up of something from this periodic table. And the cool thing about elements is that it's only one type of atom that's present. So let's just say I have copper as an element, okay? If I have a piece of copper wire, so maybe I'll draw that, and that looks like this, okay? If I zoomed in on that, kind of like looked at this piece right here and zoomed in on it, what that would look like would be little tiny copper atoms that are all side by side. And I'm going to represent those with a picture of little C's here, okay? Those C's, which are representative of the copper atoms, that's all that copper is made of. So copper is an element because it's only made up of that one type of atom, which is copper atoms. And copper is found on the periodic table right about here, number 29, okay? So what we see from there is that those elements then their smallest parts are atoms. So atom is the simplest thing that we can have for an element. So if you take, let's say, copper, the smallest unit we can get to would be a copper atom. If I try to break that down any further, it's no longer going to retain the properties of that element. So if we think about copper, one of the properties of copper is that it's copper colored. Another property of copper is that it conducts electricity. Another one is that it's metal. The smallest unit of copper that will retain those characteristics, being copper colored, conducting electricity, all that stuff, is the atom. If I try to get any smaller than the atom, what happens is that I start getting these subatomic particles by themselves here, these protons and these neutrons and these electrons. So the combination of them is what makes copper copper. If I modify that in any way, if I try to break it down into its smaller parts, I'm no longer going to have that element that I once had. Instead, what it's going to turn into is now protons, neutrons, and electrons, those smaller bits of matter. So when we look at an atom, which is what everything is made of that is matter, always contains two big regions that we look at. The first of which is the nucleus. So I'm going to zoom in on this nucleus here. And what we can see is that it is composed of some subatomic particles. So these subatomic particles that we're seeing in the nucleus are going to be the neutron. And actually, let me change my pen size here because I'm zoomed in a little bit. What we're going to see is the neutron. Oh my goodness, neutron. And we also see the proton, okay? Those are the things that exist within the nucleus. Now, what's interesting about protons and neutrons and electrons is that some of them have charges to them. As you can see here, protons have what's called a positive charge, okay? So neutrons, however, have a neutral charge. So inside the nucleus, your overall nuclear charge, this whole charge of this inside nucleus here, is going to be overall positive because it's containing protons, which are positive, and neutrons, which are neutral. So positive plus neutral makes it positive. Okay, so we find these protons and these neutrons within that nucleus. The outer regions of the atom, which are called orbitals in this case, sometimes you'll see them referred to as shells, sometimes you'll see them referred to as levels. Orbitals is the most accurate of those terms, but that's where we're going to find the electrons in that atom. So the electrons do not live within the nucleus. The reason being is that electrons are negatively charged. So if you have a positive proton and negative electrons, that's what kind of keeps the atom held together, that positive and negative attraction. They like being together, okay? Now, the thing is that those electrons are not pushed into the center of that atom. So there's some kind of force that's keeping them separated and keeping the electrons floating around the outside as opposed to being congregated in this central region. So when you look at an when you look at an atom, what you're really seeing in an atom is pretty much empty space. So if we were to, let's say, look at a model of an atom, okay? And this is kind of to scale. If I had my nucleus here, okay, nice little circle, the electrons would reach all the way out here and all the way out here. And in fact, this is not even to scale. This is probably about 100 times smaller. So the nucleus takes up hardly any space within the atom, and most of the atom is actually empty space. So the desk that you're sitting at right now, or the chair you're sitting on, it's a solid and it's made up of atoms, but almost all of the space is empty. It's just that there's so many of those atoms that you have a solid surface to sit on. But most of it's going to be this empty space that we see all through these parts in between these electron shells, okay? So what we see, what exactly makes up an atom? So all atoms are made up of essentially the same ingredients. It's just how many of those ingredients is what makes the atom special. So the first one we're going to look at is the neutron. So the neutron, again, is that particle that has that neutral charge. So what we end up seeing is that usually we represent that with a 0. So like n to the 0 is representative of a neutron. And it weighs a significant amount, meaning that its weight goes into play for the atomic weight, the weight of the whole atom, okay? Protons, on the other hand, are positively charged. So they have this little plus sign up here, okay? So we find those within the nucleus as well. And again, they are weighing a significant amount, meaning however much they weigh goes into the atomic weight as well. So the weight of the atom comes from the neutrons, the protons, and now let's see about the electrons. So electrons, remember, those are those particles that kind of fly around the outside of those nucleus in those orbitals, or what we call shells. These electrons are negatively charged. And this is nice because if they were any other kind of charge, they wouldn't be attracted to stay near that nucleus. So they're attracted to the nucleus because they have that negative charge, and the nucleus, which contains protons and neutrons, is also positively charged. So they have that positive-negative attraction. So we find these in that orbital, so not in the nucleus. They don't live in the nucleus. They live outside of the nucleus. And what's interesting about electrons is that they don't weigh a significant amount. And what that means is that when we're trying to figure out how much an atom weighs, the weight of the electrons is almost negligible. You can kind of imagine it like if you were trying to weigh, let's say, barbells. Okay, let's say you have a bunch of barbells. The neutrons and the protons in the atom are like real barbell weights, and the electrons are kind of like grains of rice in comparison. They weigh almost nothing in comparison to those neutrons and protons. They are so extremely light that when we're trying to calculate how much an atom weighs, we really don't even consider electrons in the equation because they're just so incredibly lightweight. They don't really weigh much of anything. Okay, so within our atom, we have these subatomic particles, and again, the proton and the neutron is going to be in the nucleus, and the electrons are going to be flying around. The neutrons and the protons weigh enough that we consider them when trying to figure out how much an atom weighs. The electrons don't weigh much of anything. So when we look at subatomic particles, and this is always a really popular question that comes up, we see that students often ask, like, okay, well, if atoms are made up of protons, neutrons, and electrons, what makes up a proton? Well, the answer to that is a quark. So a quark is almost like the building blocks of a proton, and quarks have to make up everything that exists. And they exist in a lot of different ways. They can exist as up quarks, down quarks, all kinds of really goofy names. And that kind of goes deeper into physics than we're going to go into this. But if you're interested in that, I'd be happy to give you some more information.